Hello and welcome back to another Python video. So sorry I have been absent recently. I've been working on a lot of projects to hopefully make videos on in the upcoming weeks. But today we'll be going over classical conditioning and how we can implement that into Python. So there are lots of libraries which do similar areas, but we're going to write our own today. Now classical conditioning, let's go over that. So it's an area of psychology. And the theory is a learning process that occurs when two stimuli are repeatedly paired. A response which is at first elicited by the second stimulus is eventually elicited by the first alone. So what does that mean in simple terms? It basically means if every time you ring the doorbell, there's somebody at the door, the dog will naturally, if you have a dog, the dog will hear doorbell and person know there's a person and naturally bark because it's their instincts to ward off people from their territory. So in other terms, you could also have, say, every time you eat cheese while watching Star Wars, every time you eat cheese you will think about Star Wars, just because the stimulus of eating cheese and the stimulus of Star Wars, it very much would be paired in this theory. So we're going to write code which would associate different inputs, and this would be helpful because we may have an array. So this is our array of data. We could have an array which is speech, and then vision, and there could be also a sensor. So let's say a temperature, and we could have within that anything. So the speech might be that is a nice ball, and the vision could be just it sees a ball, and temperature could be 40 degrees. Now the temperature has nothing to do with me saying that is a nice ball and there being a ball there or something. If we did this lots of time, then we would find this might change. So one time it might be 20 degrees, another time it's really hot and it's 80 degrees. So this is very much the sort of data that we would be working with. In fact, that doesn't need to be a 2D array. So let's create test data, and this is going to be an array, a 2D array made up of all these different inputs, which make up the code. So from this, we are hoping that we can enter data into our function. We're going to make a function which is a classical conditioning function, and then we want to return the correlation between items. So we want it to basically return the speech and the vision. That's what we want it to understand. So let's make our function. So we'll call it condition, and we want to take in an array. There are other algorithms which can do this in different libraries, but we're going to write our own just because it's a lot nicer to understand how it works. So if we want to change things, then we can. Now sometimes you might want to take a small amount or a large amount, so you can add thresholds in, but we can get to that later because it's not really important for today. So we're going to want to get the frequency of how often something appears, and we want to loop around and actually find that. So for I in array, so this will loop through this and then this and then this. So that's going to loop through each item, and then we want to loop for each of them. So for j in I. So this is going to loop through speech, that is a nice ball, vision ball, and temp 40, and then it will go back to the next line. Although I'm sure you know how this sort of code works. So let's just make a random variable called c, and that's just going to be count. So count equals 0 for k in, and that's just another like poorly named variable, but we're going to go with it. If j in k, so we want to see if this, so speech in the speech that is a nice ball, is in any of the others, we can also make it so if k is not equal, in fact we're not going to put that because it's only going to be equal to itself once, and if you do have lots of things which are the same, then you don't really need to worry. So plus equals 1. So this is going to keep adding, so every time speech, so this one is going to be, it's in this one, and it's in this one, and it's in this one, and this is going to be, it's in this one, it's in this, and yeah, and as you get the picture, but then this one won't be. So let's go back here, and we're going to append each frequency. So we're just going to get that. So now we're going to have the frequencies, so let's just print them out. So we want to condition our test. Okay, there's some sort of problem. List indices must be integers or slices. Okay, didn't have a comma. There we are. So this is found 3 times as we said it would, and this is found 3 times, and that's found once, and then once again it loops through and finds them all. So what we can do here is act on this. So we want to find the highest values which are in there, because if something's consistent, we're going to see it quite a lot. So let's do highest equals 0. We're not going to write out highest because we're lazy. For I in frequency. So this is going to loop through and find each of the frequencies, and just do if I is greater than h, then h equals I. And yeah, that's just going to remember what the highest value is. So then let's get a counter. That's going to be 0. We're going to have just a new array because here this is the main bit where it's going to gather all the big values and important values. So let's do this is just going to be a counter variable we're going to use, so we're going to make that 0. So for I in array, we're going to loop through again. It's probably not the most efficient way, but I mean, you can always make it more efficient and look at it in your own time. So we're going to loop through each position like what we did the first time when we gathered all the frequencies. So we want to check if the frequency at the counter is greater than or equal to the highest value. And also j not in new. So we're going to add it to new. New dot append j, because we don't want to add the same thing, otherwise speech that is a nice ball will link to speech that is a nice ball, and that is not really important. We just want it once, we don't need it to link to everything. So this area here will just make sure we're not getting duplicate values, and then we're going to do plus equals 1, so that's just going to increase, and then we're going to, in fact, you know what, probably don't even need this because we just need the counter, don't we? So we're just going to plus equals 1, and that's going to count every single area, and we're doing a separate counter to this because this will be 1, 2, 3, 1, 2, 3 as it goes through, whereas the frequency, we've just gathered it as a one-dimensional array, as you can see here. So this is going to be 1, 2, 3, 4, and this won't go to 4 if there's only 3 items per row. So we will do a separate area for that, and then we will return the new array. So this will be, we're going to print whatever we get from here. So this, there you go, you can see speech that is a nice ball and vision ball is linked because these things are irrelevant. So that's how we're conditioning what's relevant and what's not, because a robot would be and a human indeed will be taking in all different values. So if I'm saying to a baby ball, am I talking about myself? Am I talking about this ball it's seeing every time I say ball? Is it seeing, it might be a dog in the background running about? Like, what am I talking about? So you want to narrow down, and this is very good for a computer system because you want to narrow down what's going on. You don't want it just looking, and every time you say, how are you? It's saying the temperature is 38 degrees outside. It's like, well, that's completely irrelevant. So this is just a fun little piece of code and you can play around with it. I'll leave a link to the download. But yeah, so you can add anything. So if oranges and lemons are both fruits and a dog is not a fruit. And then I have, I could have a cat, and then I might have an orange or oranges, and I'll have lemons again. Then we'll see what happens, and there you go. Oranges and lemons are linked, and you can have this as large amounts of data. So I played around with this code and added it into something which just kept taking all the inputs. So I would I'd type into the system, it'd split up the words using artificial neural networks, which I've covered in previous videos, and it'd split up the type of sentence, what words are significant, and then it would just enter this into a JSON file. And what it would do, it'd have so much data it'd have to look through, but then using this code, it was able to find what data is relevant and train itself. Because some of the downsides of artificial neural networks is it needs training data, and you also need to know, well, what's the answer? Because you can't just gather a bunch of sentences and train an artificial neural network, because you need to know what those sentences are. So using this conditioning method, I was able to get the computer to find out what's related. And so every time I say, how are you? And then I follow that with, I'm good, thanks. It associates that and finds what it should respond with, and then it can train itself on that. So that's very much some of the fun things you can do. It's not a lot of code, it's very simple, and you can take this code and turn it into whatever, because it's very small, and I like to think easy to understand. So please let me know if there's any questions, and thank you for watching.